Welcome back, everyone. We are now in our improve setup, and we will gonna continue with generating prototypes. Um, this section illustrates how prototypes may be used in design, and it demonstrates how prototypes may be generated from the output of the requirements activity, producing a storyboard from a scenario and an index card based prototype from a use case. Both of these are low fidelity prototypes. First, generating storyboards. The following is based on the scenario in the comment for activity 11.4. This scenario breaks down into 5 main steps. The user arrives at the one-stop car shop. The user is directed into an empty booth. The user sits down in a racing car seat and the display comes alive. The user can view various car reports. The user can take a virtual reality drive in their chosen car. So, in the previous activity, these are the example of storyboard. So first it arrives at the one-stop car shop, then the user is directed into an empty booth, then the user sits down in a racing car seat and the display comes alive. The user can view various car reports and the user can take virtual reality drive in their chosen car. While drawing the storyboard as seen in figure 12.14, the following design issues were identified. How should the reports be displayed? Should they be interactive, visual heavy, textual? What kind of virtual reality equipment is required? VR headset, immersive 360-degree screen, etc. What input devices are needed? A physical keyboard or touchscreen? A steering wheel, accelerator, and the brake pedals? How realistic should the input devices be compared to a real car controls? Should they exactly mimic car functionality for a realistic experience or be simplified? So, the questions we generate from this storyboards is this. How should the reports be displayed? Should they be interactive, visual heavy, or textual? It depends on the audience. What kind of virtual reality equipment is required? VR headset, immersive 360. So in this low fidelity such as storyboard, we're able to see the interface or the more clearer image of things that is included in the requirements. What input devices are needed? A physical keyboard or touchscreen. So another thing is that Einstein said is that you will spend like 90% understanding the problem and 10% uh, thinking about the solution, because understanding the problem is the it's not actually half of the battle. It could mean 90% of the battle, because providing solution into the wrong problem will always fail. Okay, so that's the reason why it's important. um, you may identify other issues depending on the specific context, such as accessibility for people with disabilities, speed constraints inside the booth, safety measures during VR driving, system feedback, and error handling. So this accessibility, which we will discuss, or we have discussed this already, but this also require or very useful in interaction design, because it talks about how we can provide our product into most people, including those with accessibility issues. Space constraints inside the booth, safety measures during VR driving, system feedback, and error handling. So this is a storyboard generated from the one-stop car shop scenario in activity 11.14. First, user arrive at the one-stop shop. User is directed to an empty booth. User sits down and display comes alive. User can view reports. User can take a drive in their chosen car. Generating card-based prototypes. Card-based prototypes are commonly used to capture and explore elements of an interaction, such as dialogue exchanges between the user and the product. The value of this kind of prototype lies in the fact that the interaction elements can be manipulated and move around in order to simulate interaction or to explore a user's end-to-end experience. This may be done as part of the evaluation or in conversations within the design team. If a storyboard focuses on pages or screens has been developed, this can be translated almost directly into a card-based prototype and used in this way. So basically, the value of this type of low fidelity prototype is that it allows for manipulating the design, or in this case the pages of a website, without actually doing the actual website or product. So these are usually can be done as a part of evaluation, which we will discuss in the next video on how to do. So interaction elements can be manipulated. So before we decide on the interaction elements, we are actually able to reorder the interaction elements that allow us to actually create or to test different kinds of scenarios using that combination of elements. So it can also model dialogue exchanges between the user and the product. So as we've learned in the previous chapter, dialogues is one way for us to get or gather data for it's a granular type of data gathering that is less granular than conversation data. So here we translated the pages of a website directly. So here where you want to go, destination, but the scenario represents only one path through the product, and card-based prototypes may capture multiple paths. So a scenario is only one path to our product or one case in which our product are used, and card-based prototypes may capture multiple paths. So this actually can capture multiple scenarios. So it's not like a user story in which you only discussing one scenario. Here you can discuss multiple paths. Another way to produce card-based prototypes is to generate one form, a use case output from the requirement activity. So it can also be used as a use case, because remember, a use case is actually a combination of different scenarios. So from the requirements activity. For example, consider the use case of the visa requirements aspects of the group traveler organizer presented in chapter 11. The first, less detailed use case provides an overview of the interaction, while the second one is more detailed. So for visa requirements, the first that we discussed, the first requirement is actually provides less detail, while the second one is more detailed. The second use case can be translated into card as follows. For each step in the use case, the travel organizer will need to have an interaction component to deal with. For example, input via a button, menu option, or voice. So again, this goes back to one interaction at a time. Inside, in each of this prototype or card prototype, you're focusing on one interaction at a time. Example, via button, menu option, or voice, and output via display or sound. By stepping through the use case, a card-based prototype can be developed that covers the required behavior, and different designs can be considered. So here's an example of that. The alternative courses, for example, those dealing with error message, would also each have a card, and the tone and information contained in the error message could be evaluated with stakeholders. For example, step 7.1 might translate into a simple no visa information is available, or a more helpful I am not able to find visa information for you to visit your chosen destination. Please contact the destination country's embassy. These cards can be shown to stakeholders or fellow designers to get informal feedback. In this case, we showed these cards to a colleague, and through discussion of the application and the cards, concluded that although the cards represents one interpretation of the use case, they focus too much on an interaction model that assumes a WIMP or GUI interface. Our discussion was informed by several things, including the storyboards and the scenario. One alternative would be to have a map of the world through which the destination and nationality can be indicated by choosing one of the countries on the map. Another might be based around national flags. So because of that conclusion from these prototypes, one alternative that they provided is a map of the world through which the destination and nationality can be indicated by choosing one of the countries on the maps. Another might be based around national flags. These alternatives could be prototyped using cards and further feedback obtained. So you can subsequently generate that via prototypes and then get another feedback to yet another find the better could be better solution depending on your findings. Card can also be used to elaborate other aspects of the concrete design, such as icons and other interface elements. A set of card-based prototypes that cover a range of scenarios from beginning to end may be the basis of a more detailed prototype, or it may be used in conjunction with personas to explore the overall user experience. Figure 12.16, which is this, shows the two cards we draw. The first is simply an ancient Greek pot, while the second attempts to capture the idea of a pottery seller in the market. When we stopped through the story card with a colleague and showed them these alternatives, both were found to require improvement. The pot on its own did not capture the pottery trade, and it wasn't clear what the market seller represented. But there was a preference for the latter, and feedback was useful. Mapping the overall, so again, this card prototype was useful because it allows us to get initial information without actually creating the product. Mapping the overall experience, prototyping different elements of the product helps to answer specific questions, but at some point, it's important to consider the complete user experience. This is achieved by creating a visual representation of it. These representations have various names, such as a design map in 2010, a customer journey map in 2020 by Angre, or an experience map. They illustrate a path or journey through the product or service and are usually created for a particular persona and based on a particular scenarios, thereby giving the journey sufficient context and detail to bring the discussion to life. They support designers in considering the overall user experience when achieving a particular goal and are used to explore and question the design experience and to identify issues that have not been considered so far. So it's also another way to identify issues that have not been considered. So it also illustrates a path or a journey through the product or service and are usually created for a particular persona and based on a particular scenario. So here it's more specific because it's based on a particular persona of a user. So it provides the journey sufficient context and detail to bring the discussion to life. So it provides designer in considering overall user experience on how the user actually will be satisfied in its journey towards our products. There are many different types. Let's back up a little bit. So here, basically, um, it is not less detailed, or kind of like it provides an overall user experience, not just a sample path to our product. So it actually includes persona. So you could say that it is more detailed in terms of that compared to generating card prototypes. So it provides the difference is also it provides a visual representation of it. These visual representations have various names such as design map or a customer journey map. So there are many different types of representation of varying complexities. Two main ones are the wheel and timeline and the timeline. The wheel representation is used when an interaction phase is more important than an interaction point, such as for a flight. See figure 12.17 for example. Figure 12.17 here. So here it's a overall user experience for a flight. So that's more useful because if you are focusing on interaction, not on this specific point. If your overall goal is to map the overall without specifying or emphasizing point, then that is more useful. The timeline is used where a service is being provided that has a recognizable beginning and end point, such as purchasing an item through a website. So here it has a clear beginning and end point. Therefore, so like you cannot change the endpoint. It's predictable that you will start here and then end here. Unlike with like a real world flight where environmental factors could happen. So it's more like an ethnography, kind of like ethnography, while here is like a lab testing, which we will discuss later, which is the difference of evaluation type. Uh, Figure 12.7 illustrate one structure in the kind, sorry. A range of template and canvases for generating timelines are available online. Figure 12.7 illustrate one structure in the kind of issues that may be captured, such as questions, comments, and ideas. Another important element that is often included are pain points along the journey. These may be uncovered through stakeholder evaluations or feedback from within the design team. And sometimes journeys are annotated with smiley and sad faces to include pain points. So another important elements that is often included are pain points along the journey. So in this overall experience, you're also for a timeline, an important element or emphasized points is the pain points along the journey. This may be uncovered through stakeholder or evaluations or feedback from within the design team, and sometimes journeys are annotated with smiley and sad faces to indicate pain points. So the smile and sad face is useful for this, and also it can only get that pain points by asking stakeholders or the design team, because again, triangulation. To generate one of these representations, take one persona and 2 or 3 scenarios. Draw a timeline for the scenario and identify the interaction points for the persona. Then use this as a discussion tool with colleagues and stakeholders to identify any issues or questions or pain points. Note that the journey may extend beyond the use of the product and touch on the user's relationship. Note that the journey may extend beyond the use of the product and touch on the user's relationship with the company or brand. Sometimes the focus will be on technical issues, and at other times can be used to identify missing functionality or areas of under-design consideration. So in these timelines, both design representation, you are actually not focusing in just one persona and then one scenario in the product. You're focusing also on other parts that could be part of the user overall experience, such as using other software along this journey, which you may integrate to your product in case that functionality is not yet included, but it still depend on the overall goal of the business. So here you take one persona and two or three scenarios. So again, two or three scenarios, and then use this as a discussion tool with colleagues and stakeholders to identify issues, questions, or pain points. So let's watch this. I don't know if you can hear this. There you go, guys. And then another way to capture is overall experience is user flows. Um, it focus on screen content and design. These are used particularly for mobile apps or websites and are similar to timeline customer journey maps because they capture the flow that someone may go through when using the product. User flows come in various forms but are usually represented in a flowchart showing different options and decision points through the customer journey. Generating a user flow helps determine the number of screens or pages needed to keep the user engaged, maps out different paths through the product, and support the design of individual screen. So it also determines the number of pages needed for us to engage the user. So based on this overall user experience, we will gonna estimate the number of pages of our websites. And because it allows us to see how the user actually interact with us. So here, there's another example. In its most basic form, journey map starts by compiling a series of user actions into timeline. Next, the timeline is fleshed out with users' thoughts and emotions to create a narrative. So after you create this, you then put the thoughts and then emotions to create a narrative. So here's an example of this on how we actually determine the pages from this the overall user mapping. So here, entry, welcome, select task, no, correct, details, find, search items, no items found. So here's an example journey or map for a website. This so it starts by uh, compiling a user actions into a timeline, and then a timeline is fleshed out with users thoughts. So after a timeline, before you can get to the user's thoughts and emotion, design thinking refers to an approach to complex problem solving in innovative design. It is a human-centered approach that focuses on understanding what people want and what technology can do for them. Design thinking is often described in terms of a number of phases that together evolve a solution, but there are many variations. For example, Isabel in 2020 suggests 6 phases in 2 clusters. The orientation cluster involves 3 phases: understand, observe, and synthesize, while the solution cluster involves ideate, prototype, and test. Look in IDEO.com. Design thinking observes that although it teaches the design thinking as a series of linear steps, figure 12.18, it is an iterative process that can be adaptive to specific needs. IDEO emphasizes human needs, empathy, and collaboration by looking at design challenge through 3 lenses: desirability, feasibility, and viability. So you're not just looking at desirability or the user goals, and then the function that we are providing to them. You're also checking if it is actually feasible or um, available to do in the real world. On the other hand, Bon and Ellen highlighted 2 core principles of design thinking as embracing a human-centered perspective and applying a creative mindset. So it highlighted 2 core principles of design thinking as embracing a human-centered perspective and applying a creative mindset with this human perspective. They identified 3 main phases: observe, imagine, and make. So here is the graph that I've been discussing from time to time in the previous videos, in which this evaluation phase, discovering requirements, and the prototyping actually goes hand in hand. So this is like a good representation of that. We go from frame a question to make ideas tangible, and then from make ideas tangible to gathering inspiration, to test to learn, and then from test to learn we then what did we do next? We then gather inspiration again. From gather inspiration we go to generate ideas. So there's not like a linear step that we follow to these steps. That's why it's complex. Sometimes we frame a question and then share a story, and then from sharing a story we test to learn, and then from test to learn we will make ideas tangible, and then from there we generate more ideas. So it's an iterative process, and then later we will in the next videos we will discuss how this iterative process actually integrated in the real world using agile methodology, which we discussed in the previous videos again. With such a variety of descriptions of at the process level, what is design thinking? All of these descriptions agreed that design thinking is a human-centered process that aims to encourage a creative mindset in the design team. Although the phases have different names, they basically cover the idea of understanding people in the design challenge, generating ideas to address the design challenge, and implementing solutions that can be prototyped and evaluated. So here, I don't know if this video is actually the right video, but let's just try to watch. Every version should always behave. No, this is not the video. So yeah, it was disabled, but that's fine. Comment: design thinking is similar to the approaches espoused by user-centered design, and the notion of design thinking has been embraced by many designers and organizations. Nevertheless, the way in which it has been popularized has resulted in some criticism too. For example, John believes that this surge of interest in design thinking will leave behind two benefits: validation of the design profession as real, intellectual, and valuable, and a very large need for designers who can make things. He also points out that it has been popularized at a simplistic level of detail. Design entails a creative activity supported by a number of techniques, tools, and processes. He argues that designing cannot be reduced to a particular process or a set of technologies. On the other hand, interaction design is a design activity but is often taught as a series of steps with particular techniques, as illustrated by this book. What do you think are the implications of characterizing design in this way? So because of that, this profession or the design profession has been disrespected because of this, like categorizing or like making a graph or representation like this that kind of like make design not an art but a process, which are easily can be easily done by anyone, right? As prototyping, so construction part, as prototyping and building alternative progresses, development will focus on higher fidelity prototypes and developing the final product. This is facilitated by putting together ready-made components such as a set of alarms, sensors, and lights to make a physical product, or code libraries to generate a piece of software, or both. Whatever the final form, it is unlikely that anything will need to be developed from scratch, as there are many useful, in some cases essential, resources to support development. Here, we introduce the two kinds of resources: physical computing kits and software development kits. Physical computing, specifically, it is the activity of creating physical artifacts and giving them behaviors through a combination of building with physical materials, computer programming, and circuit building. So it's a combination of physical materials, the program, and the circuit. Typically, it involves designing things using a printed circuit board, sensors, for instance, push buttons, accelerometers, infrared or temperature sensors to detect states, and output devices such as displays, motors, or buzzers that cause some effect. So if you are thinking, how are these like mobile apps are able to like create this amazing tool or mobile phone in just a short period of time? So the reason for that is that previous generation spent a heck of a lot of time and resources to create this one thing, and then they systemize that thing in order for you to not reinvent the wheel. You just need to import their libraries or do things do the actually the system or follow the system that they were able to create it. So as emphasized in this, physical computing becomes complicated. It's not just physical, it also includes programming language or software. Additionally, this emphasizes that some of these libraries or these learnings from previous generation are actually essential. So it's not like you have a choice, but no, you don't. One of the earliest was Arduino in 2009. The goal was to enable artists and designers to learn how to make and code physical prototypes using electronics in a couple of days. Having attended a workshop, the toolkit is composed of two main parts: the Arduino board, here, which is the piece of hardware that is used to build objects, and the Arduino Integrated Development Environment, which is a piece of software that makes it easy to program and upload a sketch, Arduino's name for a unit of code, to the board. A starter kit for Arduino typically includes various lights and sensors. The Arduino board is a small circuit that contains a tiny chip, the microcontroller, It has two rows of small electrical sockets that allow sensors and actuators to be connected to its input and output pins. Sketches are written in the IDE using a simple processing language and then translated into the C++ programming language and uploaded to the board. The Arduino board has been used in a multitude of projects around the world, and at the end of 2021, 10 million of them had been sold. Example products made with Arduino include the plant watering system, a basement flood alert, light switches for remote or contactless operation, and even a robot bartender. See Instructables.com. So there is a robot as well that has been created, a watering system, but basically the IDE was created using a simple processing language, and then it was translated or converted to C++ programming language, and it is uploaded to the board. So the simple structure of this is the two rows of small electrical sockets. It allows sensors and actuators to be connected to its input and output pins. Sketches which are written in the IDE convert it to a C++ programming language. So it's amazing creation, but it was rooted on the few simple principles. So the electrical and electronics. Electrical, which is the study of how electricity provides energy, and electronics, which is a study of how we can make this energy or electricity produce in a specific way using these electronics such as this sensors and actuators. It can also use accelerometers, etc. Lilipad is a set of sewable electronics component for building fashionable clothing and other textiles. Other kits have been developed from these, including for a smart home, various domestic and fun robots, and a range of educational projects. Starter packs are readily available for all of these Arduino-based toolkits. Other kinds of easy to use and quick to get started physical toolkits intended to provide a new opportunities for people to be inventive and creative include electronic kits, Spear.com, Raspberry Pi, so it's kind of similar to Arduino, and Makey.com. Unlike Arduino, the microbit board contains a number of built-in sensors and a small display so that it's possible to create a simple physical computing system without attaching any components or wire. If desired, external components can still be added, but rather than the small electrical sockets of the Arduino, the microbit has an edge connector for this purpose. So it's kind of like an improvement of Arduino. So instead of the external can be added using small electric edge connector instead of these small electrical components or socket that use like electronics that could be that is often easier to break. So it a number of built-in, so the sensor are built-in, and a small display so that you can immediately create a simple computing device. So here's an example of that, BBC Micro Bit. So it have 25 light, 2 buttons, USB connector, radio Bluetooth antenna, reset button, battery socket, compass. So it's kinda how you actually create these mobile phones. Physical toolkits are readily available and have wide use and appeal. For example, when in 2020 have developed a kit for use by IoT practitioners to investigate alternatives for emerging technologies, and Lee in 2020 have developed a toolkit for prototyping e-textile wearables. Toolkits are often used by children or students in a formal educational setting or by designers to enable them to start creating small electronic gadgets and digital tools. The maker movement emerged in the mid-2000s following the footsteps of the personal computer revolution and the internet. Some viewed it as the next big transformation that would modernize manufacturing and production in 2014, whereas the explosion of the web was all about what could be done virtually. With the proliferation of apps, social media, and services, The maker movement has transformed how people make, buy, consume, and recycle physical things, from houses to clothes and food to bicycle. At its core is a desire to collaboratively craft physical things using a diversity of machines, tools, and methods. SDK. So if we have like a physical IDE, we also have software IDE. A software development kit is a package of programming tools and components that supports the development of applications for a specific platform. For example, iOS on iPhone and iPad, and for Android on mobile phone and tablet apps. Typically, an SDK includes an integrated development environment, documentation, drivers, and sample programming code to illustrate how to use the SDK components. Some also include icons and the buttons that can easily be incorporated into the design. While it is possible to develop application without using an SDK, it is much easier using such a powerful research, and so much more can be achieved. For example, the availability of Amazon's Alexa Skills SDK has facilitated the exploration and development of a range of applications for voice interfaces, including education, mental health, and fitness tracking. An SDK will include a set of application programming interface that allows control of the components without the developer needing to know the intricacies of how they work. In some cases, access to the API alone is sufficient to allow significant work to be undertaken. For instance, AG in 2014 only needed access to the APIs. The difference between APIs and SDKs is explained in box 12.7. So SDKs consist of programming tools and components, while an API is the set of inputs and outputs. That is the technical interface to those components. To explain this further, an API allows different shaped building blocks of a child's puzzle to be joined together, while an SDK provides a workshop where all of the development tools are available to create whatever size and shape blocks you desire, rather than using pre-shaped building blocks. An API therefore allows the use of pre-existing building blocks, while an SDK removes this restriction and allows new blocks to be created, or even to build something without blocks at all. An SDK for any platform will include all of the relevant APIs, but it adds programming tools, documentation, and other development support as well. So in-depth activity. The in-depth activity builds upon the requirements activities related to the booking facility introduced at the end in the previous video. Based on the information gleaned from the activity, suggest 3 different conceptual models for this system. Consider each of the aspects of a conceptual model discussed in this chapter: interface, metaphor, interaction type. Interface type, activities it will support, functions, relationships between functions, and information requirements. Of these conceptual models, decide which one seems most appropriate and articulate the reasons why. Using the scenarios generated for the online booking facility, produce a storyboard for the task of booking a ticket for one of the conceptual models in step 1. Show it to 2 or 3 other people and record some informal feedback. Considering the product's concrete design, sketch out the application's initial interface. Consider the design issues introduced in Chapter 7 for the chosen interface type. Write 1 or 2 sentences explaining your choice and consider whether the choice is usability consideration or a user experience consideration. Sketch out any experience map for the product. Use the scenarios and personas you generated previously to explore the user experience. In particular, identify any new interaction issues that had not been considered previously and suggest what could be done to address them. How does the product differ from applications that typically might emerge from the maker movement? Do software kits have a role? If so, what is the role? If not, why not? Summary. This chapter explored the activities of design, prototyping, and construction. Prototyping and scenarios are used throughout the design process to test ideas for feasibility and evaluate them for feedback. So it is used for testing feasibility. If the product will actually can be used in the real world, and it also used to evaluate them for then developing new requirements. So we here, it's kind of hard to like describe prototyping because you prototype in different like order in this representation here in different order. So it's kind of like hard to describe if it's uh, the first thing that you're gonna do is to gather requirements or to actually evaluate it, right? Sometimes you need to do the prototype after your test evaluation. Sometimes you need to do it before. So we have looked at the different forms of prototyping, and the activities have encouraged you to think about and applying prototyping techniques in the design process. Key points: prototyping may be low fidelity such as paper-based or high fidelity such as software-based. High fidelity prototypes may be vertical or horizontal. Low fidelity prototypes are quick and easy to produce and modify, and they are used in the early stages of design. Ready-made software and hardware components support the creation of prototypes. There are two aspects to the design activity: conceptual design and concrete design. Conceptual design develops an outline of what people can do with the product and what concepts are needed to understand how to interact with it, while concrete design specifies the details of the design such as layout and navigation. We have explored three approaches to help you develop an initial and conceptual model: interface metaphors, interaction styles, and interface styles. Again, these three approaches will only help you to get the initial conceptual models, but it's not like a required step. So here, an initial conceptual model or design, develop an outline on what people can do and the concept they need. An initial conceptual model may be expanded by considering which functions the product will perform and which the user will perform, how these functions are related, and what information is required to support them. So it could, after we develop that using those interface type, interaction types, or style rather, and then interface style, and then interface metaphor, we can now ask which function it will perform, how it is related, and what information is required to support them. Again, most people forgot what in this question, what information or data it is required, and how those functions or the system can do are actually related. Scenarios and prototypes can be used effectively to in design to explore ideas. So after you did these basic things, you can use the scenarios and prototypes. So again, we have different ways for generating prototypes. We have a storyboard, we have overall user experience, and we also have card-based prototypes. Physical computing kits and software development kits facilitate high fidelity prototyping and transition from design to construction. So again guys, we'll see you in the next video. Goodbye for now. Thanks.